In this video, we're going to talk about how to solve exponential equations. To solve exponential equations, that means we're going to need to use logarithms because logarithms are the inverse of exponentials, just like adding is the inverse of subtracting, squaring is the inverse of square roots, etc., etc. So what we first need to do is have it look like a base to an exponent equals a number. If it doesn't look like that, then we're going to finagle until we can get it to look like that. And now what we're going to do is we're going to take the log of both sides. So I'm going to do the log of the left side and the log of the right side. So I'm going to rewrite it while we're doing notes, but you don't have to necessarily be rewriting it every time. And then log 14. Now, when we did exponent properties in the last video, we talked about how if it's an exponent inside a logarithm, we can bring it out to the front like a coefficient. So we're going to do that. Bring out anything that's in your exponent, in this case 3x, to the front of your problem. And now what my goal is to get x by itself. In this case, what I'm going to need to do is divide by 3 log 4. Divide by 3 log 4. And you could do that in a couple steps, or you could just do it in one. And when I do this on the calculator, I am going to get that x equals 0.63. We're going to do to the hundredths, so 2 decimal places. Now, what you want to be really careful of when you type it in the calculator are parentheses. Anytime you have multiple things in the denominator, put parentheses inside your calculator. Same thing with the numerator. If you want to just always be careful, put parentheses around your numerator divided by parentheses around your denominator. That's the way to play it safe. So I'm going to be doing the odds, and then I'm going to give you a chance to do the evens and check your work. So the next odd one, number 3, I don't have my base by itself. What is the base? The base is the big number next to the exponent. So here's my exponent. The number that it's the exponent of is 7, just 7. So my first goal in life is to get that 7 by itself. So you can kind of think of it as if that blob I drew right there was a b. 3b minus 3 equals 6. And how would I solve that two-step equation? I'm treating this whole little box as a variable. Well, my first step would be to add 3. So 3 times 7 to the x minus 1 equals 12. Then I would divide by 3, and I would get 7 to, whoops, I did that wrong, sorry. 9 equals 3. Okay? Once I get that, it looks like problem number 1. So we're going to do the log of both sides. Log on both sides of 7x minus 1, log of 3. I can bring my exponent to the front. Now, when I do that, I'm going to put parentheses. Telling you, parentheses are the key to life. If you're not putting lots of parentheses, you're doing something wrong. So log 7 equals log 3. Now, there's a couple ways that you could go about doing this that are going to give you the same exact answer. So, you know me, I could care less as long as you're getting the right answer. But I'll tell you what's going to work on all problems is to distribute. So I'm going to distribute that first, and I'm just going to bring all my work up here. So x log 7 minus log 7 equals log 3. Now, what you want to keep in mind is that log a number is just a number. So my only variable in this problem right now is this x. So it's really a two-step equation at this point. I'm going to add log 7 on both sides, and I'm just going to leave all of this in log form until the very end, and then I'll type it all in the calculator at once. So I have x log 7 equals, those canceled, and I have log 3 plus log 7. Now what you don't want to do is add that. Don't try to make it log 10. Not true. We're just going to leave it like that. Don't be tempted to change that. And now I need to get x by itself. So x is being multiplied by log 7. So I'm going to divide by log 7 on both sides. And I'm going to type all that junk in the calculator right there. All of that. But you need to put parentheses. If you aren't putting parentheses, whew, it's going to be sad. It is going to be so sad. All right. Let's see. X equals 1.56. All right. The other thing you could have done, or, oh, that's my next slide, JK. Or what you could have done, I'm just going to write it at the bottom, you could divide by log 7 on this step, and then add 1, but you'll get the same answer. Once again, don't care. Equivalent. If you don't get the same answer, you did something wrong. Okay, so in number 5, here's my base, all about that base. Okay, how do I get my base by itself? Well, it's attached to this -2 with multiplication, so I'm going to divide. And at this point, we're going to use our brain. Can I raise 6 to any power and get out a negative number? No. No solution. Move on with your life. All right, so what trips us up with number 7? Number 7, we start doing some crazy stuff where I have 2 bases with exponents on both sides of my equation. So what our first step is going to be the same. We're going to take the log of both sides. So log of 4 to the 2x plus 3 equals log of 3 to the 3x. Now I'm going to bring both of my exponents to the front. So parentheses 2x plus 3, like my dramatic touch there. 2x plus 3 log 4 equals 3x log 3. And now you'll see we have x's on both sides of the equal sign. So when we have this, if you remember when we did the inverse of rationals and we talked about getting all the x terms on one side and all the numbers on the other side, it's pretty much the same idea. I'm going to distribute, though, first this log 4 to everything. So that would give me 2x log 4 plus 3 log 4 equals 3x log 3. And now what my objective is to get all the x terms, so there are my x terms on the same side. So since the 3x one is kind of lonely over there, I'm going to subtract 2x log 4. And y'all are in pre-calculus, so if you don't need to show me every single step, bless, we're good, move on with your life. Okay, so the left side is 3 log 4, and the right side is 3x log 3 minus 2x log 4. Yes, these problems are long. It's okay. Don't complain. All right. The next jump that you need to make is that we're going to factor out the x that's on whichever side. So in this case, it's on the right-hand side. So we're going to factor that out. And that just leaves me with 3 log 3 minus 2 log 4. In my infinite wisdom, I have run out of room. So all I'm going to do is rewrite that exact line right here up at the top. That was the most beautiful. No, that's just not going to be redeemed. That's a horrible arrow. This is supposed to be an arrow, y'all. Okay, 3 log 4 equals, there's a reason I'm rewriting all this. 3 log 3, we have to have the dramatic finish. Minus 2 log 4. Okay, all of this stuff right here is being multiplied to x, and how do I get rid of multiplication? We're going to divide, so on both sides, I'm going to divide by 3 log 3 minus 2 log 4. Both sides divide by 3 log 3. Whoops, didn't change to the bin. There we go. 3 log 3 minus 2 log 4. And then what are we going to do? Type it in the calculator. What do you need to have? Parentheses. Parentheses. There we go. Make sure you type in parentheses. And in one fell swoop, we're going to get that our final answer is when I turn to the correct page of my notes. 7.95. Alright, wasn't that super duper fun? Oh yeah, you know what would make it more fun? Another example. So let's do number 9. Yes, y'all, I'm a little bit loopy today. That's okay. So first step is to do log of both sides. Log it up. Log it up. If you can do the log and bring your exponent in front at the same time, guess what? That's awesome. So that's going to be my second step, is moving that exponent in the front. What do you need? Parentheses. I just imagine y'all out there saying parentheses back at me. Wouldn't that be beautiful? All right, equals 5x minus 2 log 3. Now, we have a whole bunch of junk on both sides, so we're going to distribute all this stuff. Distribute. That's what our next line is. So 2x log 5 plus 3 log 5 equals 5x log 3 minus 2 log 3. And I mean, could you be typing in these logs on the calculator and doing all this junk with decimals? Sure, but you're really not going to like life, so we're just not going to do that. Now what we're going to do is get all the x's on one side and all the just logs on one side. Okay, so I have x term, so I'm going to move those to the left. So I'm going to have 2x log 5, and I'm moving the 5x to the left, so it's going to be minus 5x log 3, and then I'm going to move my just plain old logs to the right. So that would be negative 3 log 5 minus 2 log 3. And we're literally almost done, okay? So hold on, you can do it. We're going to factor out the x on the left side. So when I factor out the x on the left side, 2 log 5 minus 5 log 3 equals the stuff on the right. And my final answer, you just need to divide by all the junk in parentheses. 2 log 5 minus 5 log 3. 2 log 5 minus 5 log 3. Now, it's entirely possible that's the ugliest problem that you have had to do in math yet, but it wasn't horrible. It just has a bunch of words in it, a bunch of logs. Put parentheses. Your calculator is not going to give you the right answer if you don't put parentheses. Have I emphasized that enough? Put parentheses. Okay, so you're going to type all that junk in the calculator, and it's just going to shoot out to you that x equals 3.09. Okay, the last thing we need to talk about is finding inverses of logs. Don't you know it's coming back? Y'all are great at this point. The first step of finding an inverse is to switch x and y. So we're going to do that. Switch x and y. Now what we need to do is, just like when we're solving, we need to get the base by itself. So the two steps to get the base by itself in this problem is we're going to add 4. Well, x plus 4 is not like terms, so x plus 4 equals 2 times 3 to the y. Now I need to divide by 2 on both sides. That's a horrible 2. There you go. X plus 4 over 2 equals 3 to the y. Now, here's what we need to do. We are going to do log of both sides, but when we do log of both sides, we're going to choose special log. We're going to choose a special log. What's my base right here? It's all about that base. I'm going to do log base 3. And the reason I'm going to do log base 3 is that when I do log base 3 of 3y, those are going to cancel and just leave me with what I want on the left-hand side, which is just y. So I end up with y is log base 3 of x plus 4 over 2. And that's how we find the inverse. So the only difference with finding an inverse is you pay attention to your base, and you're going to do log of that base. By the way, in this entire video, I've just been doing log. You could also be doing natural log, Okay? You could be using natural log. You could be using log base 2. You could be using log base pi. You're going to get the same answer. But log and natural log are the easiest on our calculators. So that's why we do this. Okay, so what I need you to do is stop, press pause, and try the even buttons. Do not press play again until you are ready to move on with your life and check your answers. Okay, they're on the next slide. So press pause. Do it right now. And here are the answers. If you didn't get those answers, check with your teachers so that we can figure out what went wrong. Okie dokie. Make sure you show your work. Have a great one.